Welcome for Compile Design lecture video notes. So let us see the second video lecture for this. Let us see the cases of the compiler. There are 6 cases of the compiler, namely lexical analysis, syntax analysis, semantic analysis, intermediate code generator, code optimizer, code generator. So left side right test is a symbol table, which is all the variables are collected and stored in the symbol table. During this compilation, any errors are generated, that errors will be stored in error handling table. The scanner, which is called lexical analyzer. Lexical analyzer we call as a scanner. It collects a sequence of characters from the meaningful unit called as a tokens. For example, A within the index A of index equal to 4 plus 2. A is identifier. The bracket, square bracket is a left bracket. Index is identifier. Closing bracket is right bracket. Equal to the assignment operator. 4 is a number. Plus is a plus sign. So 2 is a number. Like this, all these meaningful units should be done by the scanner. Okay. The other operation it may be enter into literal into the literal table. Anything variables are there means variables are stored in the symbol table. The parser, it is called syntax analysis. It determines the structure of the program. The result of the syntax analysis or parse tree are called as a syntax tree. For example, A index of 4 plus 2 is a parse tree. The parse tree we can called as an abstract syntax tree. It will contact syntax tree or maybe called a parse tree looks like this. All the internal nodes are called as variables. All the external nodes are called the terminals. Okay, so all the identifiers are called the terminals. All the identifiers, numbers are called as a terminal. All these internal nodes are called as variables expressions. They called the parse tree. Similarly, like a syntax tree. Total the contents from the parse tree is called as a syntax tree. So both are similarly same concept for the parse tree and syntax tree. Semantic analyzer. The semantic analysis of the program's meaning opposite to is a syntax or structure that determines some of its running time behaviors prior to the execution. Semantic Static semantic declares a type check-in, attributes the extra pieces of information computed by the semantic analyzer. An example, A index equal to 4 equal to the syntax tree annotated with the attributes. The annotated syntax tree is assignment expression, sub expression, additive expression, identifier is identifier A, identifier index, identifier 4, identifier 2. The source code optimizer. The earliest point of most automation steps is just after semantic analysis. The code improvement depends upon only the source code as a separate phase. The individual compiler exhibits a wide variation in the automation kinds as well as the placement. For example, A index equal plus 2 C. So optimization, what can be reduced in the way of memory, in the way of repeated operand that can be reduced from the automation techniques. It's called automation annotated or stay or syntax. The automation intermediate code. T equal to 4 plus 2. A index equal to T. That assigning to is value. T equal to 6. A index equal to T. A index equal to 6. See that automation code for this as possible as code. A index of 6. New index to R0, variable R0. Then multiply R0 with 2. Then move that R address of A1, what is there in the address of A1, move to R1 register, then add R1 and R2, move the pointer to move the 6 to address of 1. This is a possible sequence of code. The target code optimization improves the target code generated by the code generator. Address mode fusion, instruction replacement, as well as a redundant elimination. This is the main thing for the code optimizer. Suppose this index to R0, 2 to R0, move to R1, A to address of A to R1, add this to R1 or 2, move to address of A to this is can be modified, simplified by the new index to R0, shift to R0, new address of A R1, this will be the same result using code optimization technique. The principles of data structure for the communication among the cases tokens. A scanner collects the characters in the token as well as the value of the enumerated data type, which is called token. May also preserve the string of characters or other derived information such as name of identifier, value of a number token, or may be called as a single global variable or any other token should be called as an tokens. Syntax tree, the standard pointer based structure generated by the processor. Each node represents information collected by processor or letter, which may be dynamically allocated or stored in the symbol table. The node requires different attribute, different kind of language structure, which may be represented as a variable record. Symbol table gives information associated with identifiers, functions, variable, constant data. Interacts with almost every process of the compiler. Access operation need to be constant time. One of several unstable and used for the symbol table also. What is a literal table? Stores constant and strings reducing size of the program. Quick instruction and the look up the essential for the data structure. Intermediate code. This is called as an intermediate code. The array of texting and temporary text are a linked list of structure depending on the kind of mesh code. The creator's code is called as intermediate code. Solve the temporary files. Solve the product of intermediate steps during the compilation. Solve the program of memory constraint or backwards addressing during the code generation. Structure of compiler. Multiple views of different stages. Logical structure, state structure, sequencing of operation. The major impact of the structure. Reliability, efficiency, usefulness, maintainability. So analysis of the sequence. The analysis part of the compiler analysis for source program to compute its properties. Lexical analysis, syntax analysis, semantic analysis, as well as automation. More mathematical and better understanding. Yeah. Synthesis part of the compiler produces translated code. Code generation as well as automation. More specialized. Two parts have to be changed independently of the synthesizers. Front-end, back-end. The operation of the front-end and back-end considers the scanner, parser, and semantic analysis as well as intermediate code synthesizers. Operation of the back-end depends upon the target language. Code generation analysis and automation analysis. The intermediate represents the medium of communication between them. The structure is very important for the compilation portability. Process. With repetition of the process, the entire source program is generated code or referred to as a process. Process may or may not correspond to the cases. So combine the three cases into one pass. There is one pass compiler, two pass compilers are there. Multi-pass compilers also are. This is called the pass of the compiler. Language definition of the compiler. Lexical and syntax structure of the program language. Regular expression, syntax programming. The semantics of the program language in English is the language reference manual or language definition. Compiler options of the implementation. Mechanism of the implementation with the operation system. Input and output facilities. Access to the file system, target system. Options to be used for the various purposes. Specification of listing characteristics, code automation, options, error handling. This is a table which is all the during the compilation, whatever errors are identified by the process of the compilation, all the errors to be sent and stored in the error handling table. If any exception handling, then generate extra code performs suitable runtime test for the generate and guarantee for all such errors to cause an abbreviate event during the execution. The third language of the compiler concept, machine language. Compiler to execute in the language is a compiler called the smart target language. Compile view new compiler which is existing compiler. Another language is called the compilation produces a cross compiler. Case of the compiler. These are the different ways of the compiler. So this input source code is a Linux analyzer. The source code will be separate all the tokens in the input string. This is a parser, it's called syntax analyzer. The syntax analyzer which creates a syntax tree for the given source code. A equals B plus C, syntax tree will be created by the second phase of the compiler. Semantic analysis. So annotate the process, the meaningful it will be, to check the meaning of the process tree or syntax tree. Intermediate code generated, we convert to intermediate code like a mnemonics, like a assembly language code. We convert to the given process into assembly language code. Code optimization. It is possible to reduce unwanted things or memory or repeated variables is there, that will be removed by the code optimizer. Finally, it will generate the code generator. So assembly code will be generated. The people optimizer, anything is possible to reduce again in this assembly language code, it's possible to reduce. That is called the people optimization. Grouping of phases, front end, back end grouping, and so on, all 6 phases. Compiler construction. These are the scanner generated, parser generated, syntax direction, translation engine, automatic code generated, data flow engine. Thank you.